Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concepts of precipitation reactions and aqueous solutions and give an introduction to solubility. So, what is a precipitation reaction in general? Well, if I take two aqueous solutions, for instance, they could be gaseous solutions, and I mix them together, I could form what's called a precipitate. All right? And it is the solid that is formed when we combine the aqueous solutions. Now, you form a precipitant in double replacement reactions, in which, as a solution, it might be a liquid, the two aqueous solutions, but then when you mix them together, some of their parts mix together and interact, and they start to solidify. So a precipitation reaction is a reaction in which a precipitate forms. So a precipitation reaction is a reaction in which a precipitate forms. The table you can find on destinationeducation.com is right here. So memorize this. Okay. So we know what's soluble. Well, Group 1 alkali metals are soluble and compounds that contain ammonia, except for the carbonates that have group 1A. So the 1A alkali metals and H4, those are the cations, the plus compounds. Carbonates, if they're attached to the anion of a carbonate, then it's going to be a solid. Okay, nitrates are soluble, whereas if we have sulfites, they're insoluble. Okay, just go through, memorize this table. So you can use acronyms to help you memorize these. Like for the sulfates that are soluble, it's can anyone please hug Bob? No, that doesn't work. So use acronyms to memorize these. Like for sulfates that are soluble, it's can anyone please hug Bob Smith? Can anyone please hug Bob Smith? All right. If you have a 1A or 2A with a sulfite, it's insoluble. Okay. Just do no cards. Okay. And for instance, on this one, you would have 1A and NH4 on one side, and then on the other side, it should say soluble, and then the exceptions, okay, which are the carbonates, so forth all the way down. Now, solubility is kind of what happens when we're just looking at the interaction of the solute and the solvent, okay? So think of your iced tea. All right, you're pouring sugar into your iced tea, and at first when you're stirring it, you don't see the sugar at all because it's dissolving into the solution. Right? Solutions are made up of solutes and solvents. A solute is the substance in the mixture that is present in small amounts, like sugar, for instance. Relatively speaking to the tea in the cup, is present in smaller amounts, and the solvent in this case would be the tea because it's present in larger amounts. Okay, so when we have a solute being placed in solvent, the solubility is maximum amount of the solute, or sugar in this case, that will dissolve in a given amount of solvent at a given temperature. Okay. So that's your solubility. And again, we went over those rules as to what will dissolve in these solubilities. So we're going to go more into solubility in the next handout. But just for now, I just want to introduce what solutes are versus solvents. Okay. So in aqueous solutions, when you have a solute placed in a solvent, it can ionize or dissociate depending on whether it's an ionic compound or a molecular compound. If you remember, elements that are metal and non-metal bonded together form ionic compounds, Okay, and when placed in water, they ionize, like sodium chloride, table salts. Okay, or like the example, we would have to think of like an acid. Acetic acid would ionize. Some things ionize to a greater extent, and other things don't ionize to that great extent. If they ionize to a great extent, it's called a strong electrolyte, and if it's ionizing minimally, it's called a weak electrolyte. So, some of the binary acids, for instance, are water soluble and will dissociate completely. So let's take a look at that. So again, non-electrolytes, substances dissolve in water to yield a solution that does not conduct electricity. Whereas electrolytes, whenever they're dissolved in water, they're going to give you a solution that is able to conduct electricity. Weak electrolytes partly dissociate, mostly undissolved and not ionized. So if you're thinking of molecular compounds, acids, except for the strong ones, like the acetic acid example I cited earlier. Strong electrolytes are dissociating completely. All water-soluble ionic compounds are going to do that. Okay, so your NaCls and stuff like that. That's basically it. You can find that solubility table on the destination education handout, as well as this aqueous solutions handout. Will be there. No, just pretty much everything I gave you on this video. On part 2 of the solubility discussion, we will be going in much more detail. We'll be looking at the details of solubility in soluble salts, looking at KSPs and the ion product. What happens when we put precipitants in solutions? Will they ionize or not? And we will be looking in further detail at the common ion effect. How does that affect our KSP values? And so forth. All this again is on destination education. All right, so make sure you get the foundation solid before we move on to all this to do with the equilibria of actual ionization reactions or dissociation reactions. I hope I've clarified enough for you to get started. Practice, practice, practice as always. Thank you and have a nice day. Spectator ions and molecular ions, and we will be discussing